All right, I'm hoping to get the recording started. There it goes. I think last period it never recorded.
Oh, really?
All right. I was looking at the Some Dog Challenge, and I saw that Lily and Aristotle and also Chiamaka already finished. And a bunch of you, 50 problems.
Okay.
And Grace is partway there. All right. So I have 5 of you that need to jump in. If you guys ever see RJ and you want to tell him to do the challenge, that would be great because I'm having a hard time catching up with him.
Mm-hmm.
Does he come to like religion or language arts?
Mm-hmm.
Yeah.
Okay, good. All right, it looks like we were working on Pythagorean theorem.
Yep.
Do you guys like it as much as I do now?
Yes. Mm-hmm. Yeah, I like it a lot. It's really easy and simple.
It's okay.
Yeah, I like it.
It's super easy and it's super fun.
Okay.
I still
Is the Pythagorean theorem a squared plus b squared equals c squared? No. Remember, it's in a right triangle. The square of the hypotenuse equals the sum of the squares of the other two sides. Okay. You guys did page 579 to 581, 1 to 29 odds.
Mm-hmm.
Okay. Number 1, Aristotle, what you get?
X equals 12.
Good. See, and that's the Pythagorean triple. All right, number 3, Grace.
I got root 272. But I'm gonna check if that can be simplified. Yes, it can. 2 root 68.
Well, what did you end up with?
2 root 68, or can it be simplified?
All right, do 60. Maybe it's
4 root 17.
We should end up with 4 root 15.
60 12 by 4. I got 17.
You got 4 root 17?
Yeah.
All right. Let me work that one out. Okay. So our hypotenuse is 16. I got to get my calculator handy and square that. That's 256. All right. I'm going to subtract 16. I'm going to subtract 4 squared. So that's going to be root 240. Is that what you had to start?
Oh, I see where I went wrong. I didn't subtract, I added.
Oh, okay. And 240 is 16 times 15.
Okay.
Okay, so that'll give me 4 root 15.
Okay.
Make that, guys. Okay. Number 5. So I'm going to flip it over to the next page. This was a multiple choice. What is the length of ln in feet? Brian?
D.
I'm sorry, I can't tell if you said B or D.
D, like
D.
dog.
Yes, good. D like dog. All right, number 7, determine if it can be a triangle, and if yes, is it acute, obtuse, or right? We were just looking at those at the end of class yesterday. We didn't really talk about them that much. Lily, what did you do for number 7? Could that be a triangle? Oh, Lily, you're muted.
Sorry.
That's okay.
Yes, and obtuse, I said.
Yeah, very good. Because if we add the two shorter legs, we get 34. That's bigger than the third side. So that's a yes. And then we have to see if 26 squared is equal to 16 squared plus 18 squared, less than or greater than. All right, so 26 squared was 676. And this was 256 and 324. So it was a greater than. Right, if we get a greater than, it is obtuse. Less than, acute, and equal to makes it a right triangle. All right, number 9, Colby.
I have 20.
11, Luke.
Root 21.
13, Aristotle.
Oh, this is the interesting one.
I was just
Root
going to
10
say,
Yeah.
Root 10 over 5.
yeah,
Wait, can you show that one, Mrs. Palmer? Because I got
sure. Okay, yeah. So you look at this one, and I like Aristotle's adjective for it, interesting, right? Right away we see fractions, and we're like, ugh, right? And then we get ourselves together and we say, we're not scared of fractions. We just don't really like them. We're looking for the hypotenuse. So we're going to take those two legs, 3/5 and square it, and 1/5 and square it. Okay. So we'll write our thing sort of like
Yeah.
that. Okay. All right. 3/5 squared, that's going to be 9 25ths plus 1 25th.
10 25ths.
So 10 25ths. We have to take the square root of 10 25ths.
So then it would be 10 minutes. Okay, that makes sense.
All right. Luckily, 25 is a perfect square.
Yeah.
So we get root 10 over 5. But if 25 was not a perfect square, it would have been even more interesting because we would have had to rationalize the denominator. All right. So that takes us to 15, Brian.
15, I got 34.
Good. 17, Colby.
30.
I have 70.
Okay.
Just go back and check that one. All right. 19 is one with the diagram, but it does make a triangle. Again, it has fractions, so that's,
Oh, this is an interesting one.
yeah, we'll call it interesting. What is the length of the horizontal portion? Is there anyone who wants to jump out and say what they got? Luke?
Yay. Root 319 over 6. Uh-oh.
That's not what my book is saying. I didn't work this one out, but I will. Let me see. Maybe we should do a survey on this one. All right.
Oh, I did it wrong.
All right. Lily, what did you get for number 19?
I got the same thing as Luke.
Okay. What is that again, Lily?
Root 319 over 6.
All right. So I have 2 votes for that. Okay. Grace, what did you get?
I did it wrong. I forgot to I just
Okay. Colby?
I got 3.5.
3.5.
Wait
Okay.
a minute.
Brian?
I put 2.4.
2.4. Aristotle?
I got 3.5.
Another vote for 3.5. Okay. So it looks like this. So I have 2 votes for root 319 over 6.
wait. I think I'm
One not sure. 2 for 3.5, and 2.4 one person. Okay. So let's take a look at it. It is making a right triangle. Okay. So I'm going to say 1.5 squared equals b squared, or plus b squared equals 3 1/3 squared. All right, I'm not going to use decimals because 1/3's going to keep repeating. So I'm going to turn that into 3 halves. Okay, 1.5 is the same thing as 3 halves. And 10/3 for the hypotenuse. Okay, so I have 9/4 plus b squared equals 100/9. All right, so we're here. All right, we're going to square 3 halves and get 9/4. We're looking for the other leg, and we're going to square the hypotenuse. We have 100/9. So we have to take 100/9 and subtract 9/4. Okay. Fortunately, I do this many times a day because 4th and 5th grade are both subtracting fractions right now. Common denominator between 9 and 4 will be 36. Okay, 100/9 is 436. And 81/36. I see where you're getting the 319 at. I subtract that and I get 319/36.
I just redid it and got root 10.
So b squared equals 319/36. And you took the square root of both sides. So that's root 319/6. All right. What is the length x? Okay. Technical difficulties with my calculator. Still. I might have to come up with a calculator on the computer. All right. Guys, do root 319/6 on your calculator.
I get 7.29, and then it goes on and on.
I get 2.97.
I like the 2.97 because it says about 3 feet is the answer.
Oh, so then yay.
Yeah. All right. 319, take the square root of it and divide that by 6. Yep. So that is right. Root 319/6 is good. You get 2.97 and the answer is about 3. Okay, so it kind of looks like this. All right, let's do 21. This is it a triangle? 21, Aristotle.
I said yes, and it's a cube.
It is a yes, but it's going to be obtuse because when you square 21, you get 441.
Mm-hmm.
And then if you add 49 and 225, you'll get, you're only going to get 274. So 441 is greater than that. All right, so if your hypotenuse squared is greater, then it's obtuse.
Okay, I have them all backwards.
Okay. 23, Brian.
Acute.
Let me look at it. Sorry. Yes, it is a triangle. It is a right triangle, actually.
Yeah.
If you square 20.5, you'll get 420.25. And then you add the other two, you get the same thing. Okay. So they're equal. So it is a right triangle. So what I don't want you guys, I'm not sure that you did this, any of you, but like just to guess, you have to do the numbers because just by looking at it, it's too hard to say. 25, Colby.
Cute.
Yes, good. Yes, it is, and it is acute. All right, 2 more. 27, you had to find x. Grace, what did you get?
15.
Good. And 29, Lily.
I got give me a second. My dog stole my paper.
Okay.
Sorry.
Sorry.
Okay. I forgot to one, sorry.
You forgot what?
I did the wrong I didn't do that one.
Oh, okay.
Never finished that one.
Okay, Luke. 29.
4 root 6.
Good. Okay. All right, guys. That is Pythagorean theorem. Pretty good. Minus when we have fractions, sometimes it's a pain. Okay, but that's a formula that you will use throughout other math classes, but it's not one that's too hard to memorize. And the other thing you need to know is to tell if a triangle is acute or obtuse or a right triangle. Right. The next section that we're going to do is kind of fun. It's called special right triangles. I really like this section. It's on page 586. All right, so we're still dealing with right triangles, and we know how to use Pythagorean theorem. But Brian, you're going to love this. This is going to be your favorite thing you've done so far this year in math.
Yay.
Okay. There are special properties of triangles. If you have a right triangle that's a 45, 45, 90, there's special properties. And if you have a 30, 60, 90, there's special properties. Okay. So on page 586, they're going to start talking about the 45, 45, 90. So that's an isosceles right triangle.
No.
All right. And they are going to go through like showing you why this works. But basically, what this formula is to figure out the hypotenuse. You take one of the legs. Now, the legs are the same, right? Because it's a 45, 45, 90. So it's an isosceles triangle. You got two legs that are the same length, and you have your hypotenuse. If you know one of your legs, all you have to do is multiply it by root 2 to get the hypotenuse. Okay? So if you look at example 1, it's at the bottom of the page, 586A. And this is a 45, 45, 90. And I know one of the legs is 6. I mean, they're both 6, but they only have to tell me one. And I want to know the hypotenuse. I can just look at it and say, my hypotenuse is 6 root 2. What do you think of that, Brian?
That's pretty nice.
All right, let's look at... That's just Lauren, buddy. Okay, let's look at B. One of the legs, or both of the legs, but a leg is 9 root 2. All you have to do is multiply that by root 2 to get the hypotenuse, okay? So 9 root 2 times root 2. I'm just going to show you the multiplication of roots just to refresh your memory because we're going to be doing that a lot this section. Okay. So if we have 9 root 2 times root 2, looks like that. Okay, we can multiply our roots together. Root 2 times root 2 is root 4, and it just equals 2. So anytime you have a square root, like a root 2 times root 2, it just equals 2. Root 4 times root 4, 4. Root 56 times root 56, that's 56. So that's just 9 times 2, or 18. Right? So, Brian, you could just look at that and go, oh, hypotenuse is 18.
Oh,
You
yeah.
like it?
Yes, I love this.
Okay, so, Brian, we're going to go to the top of page 587 because there's some examples.
Okay.
All right, Brian, 1A.
Okay, find x. 4 root 2.
Good. All right, Brian, find 1B.
5 root 2.
5 root 2. Good. 1C, Brian.
14.
Yes. You're going to just, I told you, right?
Yes, this is no longer abstract art to me.
Okay. Example 2, they're going to show us an example of what if you know the hypotenuse and you need to find a leg. Now you're dividing by root 2. Okay. It could be a little bit of a pain, but the example they give us is our hypotenuse is 12. So we have to divide 12 by root 2. Okay. So if I do 12 divided by root 2, I can't just leave that as my answer because I'm not allowed to have a radical in my denominator. It's like illegal. Remember the math police come and arrest us? Okay. So we have to rationalize it. That's all. We have to multiply that by root 2 over root 2. We're allowed to do that because root 2 over root 2 just equals 1. And you can multiply anything by 1, like without changing its value. We're just going to change the way it looks a little. And that's going to equal 12 root 2 over 2. Oh, and I can simplify that because 12 divided by 2 is 6. So 6 root 2 would be my final answer. Okay.
So pretty much it would just be having the number and putting root 2 beside it.
Over 2. Yep.
Okay. Then.
Okay. So if we look at 2a, though, it's not going to even be as hard as that because our hypotenuse is 5 root 2. Okay. So to find my leg, I divide by root 2, and they're just going to cancel out. That's going to equal 5.
And that's 9 root 2 beside.
Okay. 2b. I'm going to have everybody do 2b. So you're going to have to divide by root 2, and that's going to make you have to rationalize it. Okay. So we know it's 18 over root 2, but we have to rationalize that. All right. Brian's probably rationalizing it in his head right now. Mrs. Palmer's writing it out because I need to see things. Let me see. Grace, what did you get?
9 root 2.
Yep.
Yeah.
All right, here's what Grace did. 9 root 2.
Brian, I finally see how you do things in your head.
Except I skip a step in that.
I see where you. Yeah.
Okay.
Yeah, I just skipped the first half of the problem.
All right. There's 30, 60, 90s, but that'll be a good place for us to stop, like to do tomorrow. So I'm just going to give you some work on the 45, 90s.
I will be.
All right. So this is going to be on page 590 and 591.
I'm ready.
Okay. We're going to do 1 to 3. And we're going to do 8 to 10. No, 8 to 13. 8 to 17. Sorry. All right. That's it. I'll write it down so you guys can see it. It's
So
just
1 to 3 and 8 to
5 months, I
17.
guess. 1 to
So-
3 and 8 to 17.
Okay.
All right. Okay, we'll do the 30, 60, 90 triangles tomorrow, and the special properties they have. And then we go on break for Easter. So we'll have a quiz the week after Easter, probably on Thursday, on these first few sections of this chapter. Okay?
Okay, I'm on number 9.
Okay. Okay. Guys, if you have questions, come see me between 2 to 3 or shoot me an email.
Okay.
Okay?
Okay.
All right. Have a
Thank
good
you.
day.
Thanks, you too, Mrs. Palmer.
Bye-bye.
Goodbye.